All right, guys, I just wanted to give you a couple quick examples from homework 27. For those of you that aren't going to be able to be here for the lesson, a lot of this assignment, there's a lot of different story problems, and I want you trying to figure them out on your own. Once you see someone solve the story problem, it kind of takes away the challenge of the problem, which is the whole point. Once you see someone solve it, you can just repeat it yourself, and you didn't work through how do I solve this problem on your own. But I want you to have a little bit of guidance, a few examples that you can at least pull some information from. All right. So now the first thing I want you to see on this diagram, I know it's not really easy to see, but last year we had a lot of confusion with two of these words right here. The first one is an angle of depression and an angle of elevation. I'm not going to read this big long paragraph to you, but basically, if you are this girl right here and you are looking straight out here to the right, that is a horizontal line, right? You're looking straight. An angle of elevation is an angle that's created when you look, instead of looking straight, when you look up. When your sight goes from straight to up, we call that an angle of elevation. So right here it says that she has a whoa, that's hard to read. It's already there, 38-degree angle of elevation, okay? Now, whatever she is looking at, in this case, she's looking at this hang glider up here. Whatever she's looking at, if it were to look back at her, now this hang glider person, if they look straight out, they make a straight line, right? Now, if they were to look down at the person on the ground, they create this angle from looking down. If you create an angle looking down, then that is called an angle of depression, all right? Now, if two objects are looking at each other, okay, if I have stick figure person down here looking at seagull flying up here, I like drawing seagulls because look how easy that was. If these two objects are looking at each other, then theoretically you've got straight lines right here, which means that this angle of elevation is exactly the same as the angle of depression that the seagull has to look down. Basically, they're looking at the same angle to see each other. One is just looking up, one is looking down, okay? So, a few story problems using a lot of that nonsense. Now, the nice thing is about half these story problems, maybe even more than that, gives you examples. It actually draws the picture for you. It gives you kind of something to base off your math off of. And then you've got to use our sine and cosine and tangent ratios to help you solve the problem. So in this problem, it says that you cite a rock climber on a cliff at a 32-degree angle of elevation. Okay, so I am standing, and I know there's a picture here, but I'm standing here, and I see a rock climber up here. So here's a person hanging for dear life onto a rock. And that angle, when I look up, that angle that I just made is 32 degrees. And again, I know there's a picture, but I like my own pictures. Your eye level is 6 feet above the ground. Well, that's good to know. This distance right here is 6 feet. And you are 1,000 feet from the base of the cliff. So the cliff that this guy is holding on to is 1,000 feet away from me. All right. What is the approximate height of the rock climber from the ground? So we are looking for this height right here, how high the rock climber is from the ground. So it gives me some information, and it gives me, I have this picture right here of this triangle. Now remember, going back to our trig ratios, if you know an angle and a side of a right triangle, because this makes a right angle, doesn't it? If you know one of the angles and one of the sides, you can find any other side. So if I go back to SOHCAHTOA to figure out what I'm using, I know this angle, 32 degrees. I know this length 1,000. I'm looking for the length across from 32. And when I'm looking across, that usually means opposite, okay? So which one is going to use opposite? And in this case, my 1,000 is my adjacent because my hypotenuse over here is across from the 90 degrees. So opposite and adjacent, that's going to be tangent. So when I write my equation, I'm going to say the tangent of my angle 32 is going to be equal to the opposite side, because TOA is opposite over adjacent. And my opposite side is my H. My adjacent is 1,000. Now I'm looking for H, so I want to move that 1,000 over. So I'm going to multiply both sides by 1,000. So what I end up with is 1,000 tangent of 32 is equal to H. Now, if I plug that in my calculator, because I don't expect you to memorize all of those tangents and sines and cosines. So if I do 1,000 multiplied by the tangent of 32 degrees, I get 661.006. So this equals 661.006. Now be kind of careful because that gives me the height from my eyes up to the rock climber, right? That gives me that length. But the question says how high is the rock climber off the ground, which is one of my favorite things about this question, because the rock climber is 661.006 feet off the ground, but he's also an additional 6 feet up because of my eye level, right? When I made my triangle, it's based on my eye level, not based on, it's not based on the triangle starting from the ground. So I have to add 6. So my answer is going to become 667.006, and I'm willing to bet that this question probably says round to the nearest whole number or integer. So you would say 667 feet is how high that rock climber is. That guy's up there. That's pretty high. All right, next question. How many of these do I have for you? Only 2? Okay, well, we better do these really good then. The next one, an airplane pilot sights a life raft at a 26-degree angle of depression. Okay, so my airplane pilot. So here's my airplane. Do you like my stick figure airplane? It's actually a pretty good one, right? He sees a life raft. Now, without having to think too hard, the airplane is probably up in the air and the life raft is probably down here on the ground somewhere, right? This is my life raft. The airplane's altitude is 3 kilometers. What's the airplane's horizontal distance? Okay, now see, it doesn't even say that someone's in the life raft. It just says that there's a life raft. So what do I know? Well, I know that it tells me a 26-degree angle of depression. So if my airplane was looking straight ahead and looks down at the raft, I know that this right here is, whoa, let's not write in, this right here is 26 degrees, okay? The airplane is 3 kilometers high. Now, I could say right here that this is 3 kilometers. But I'm going to actually draw that height right here because I want to keep my triangle over here where I've already got an angle. So this height is 3 kilometers high. What is the airplane's horizontal distance D from the raft? So it wants to know how far away the raft and the airplane are. So what is this distance right here is what we're looking for. So I have an angle. I have a couple of sides of my angle. So let's set up a ratio. So if I'm using SOHCAHTOA, my angle is 26 degrees. I have the opposite, right? 3 kilometers is the opposite. And up here, my distance here is my adjacent. So I have opposite and adjacent, which means I'm going to be using tangent, which, guys, you're going to use tangent a lot on story problems. The hypotenuse is usually one of the least interesting numbers in the problem. So tangent's going to come up a lot. Remember, this right here made our 90 degrees, so this was my hypotenuse. And a lot of times we don't care how far away the airplane is from the raft. We want to know the distance along the ground. So I'm going to use tangent. So tangent of 26 is equal to opposite over adjacent. Well, my opposite is 3. My adjacent is what I'm looking for. So let's call that, what did they want us to call it? D. So that's going to go on the bottom. And if I do a little bit of trickery with my, well, I guess depending on who's taught you how to simplify some of these things, I'm going to multiply D on both sides, right? I'm going to multiply D over here, multiply D over here. So I end up with D times the tangent of 26 equals 3. Now, I want D by itself. So I've got to divide by tangent 26. So I end up with D is equal to 3 divided by the tangent of 26. And if I plug that in my calculator, 3 divided by the tangent of 26, I get 2.545. So D equals 2.545. And again, I don't know. It doesn't tell me how to round. Those are kilometers. So I probably want a couple decimals. So let's just say, at least for the sake of this problem, we'll round it to 2.55. 2.55 kilometers. That's how far away the airplane is. Not this distance right here, but that's how far away across the ground. That's the ground distance away from the raft, okay? All right, so homework 27. I know that's only 2 examples, and guys, I'm okay with that. I think the best benefit homework 27 has is you working through the problems for yourself. So I want you to work through those. If you're not drawing a picture, you are absolutely doing something wrong. Every one of these problems, you need to be drawing a picture. Built into your picture somewhere, you should have a triangle. So you are going to draw, you're going to find the triangle, and then you're going to use SOHCAHTOA to find your missing piece. All right? Good luck.